Alright, this is Chapter 2 of the 7th edition of Intro to Networks, or our Networks course. This recording is available for all the adjuncts at Rose State, so I'm just making it for everybody. Alright, Chapter 2 talks about how computers find each other on the network. Alright, let's continue on here. Alright, an overview. First of all, 4 address methods. We have application layer, computer names, host names, fully qualified domain names, IP addresses. There's all kinds of different ways. Okay, we're going to talk about each one of these. We're going to talk about how names work. We're going to talk about how port numbers work. We're going to talk about IP addressing. We're also going to talk about MAC addresses. So all of those things will be discussed. Okay, first of all, MAC addresses. A MAC address, which I could probably, well, if I can find out how to get up my, well, I'm going to pause for 1 second. Alright, I'm going to show you a website here in a second. First of all, I want to bring up my MAC address. Okay? I'm actually recording this on a Mac. Let's see if I can get it. Get it? MAC address. Mac. Haha. Alright, there is my information. And let's go back to, wow, this gives me a lot of crap. Okay, there's my IP address. There's my Ethernet address right there. Now I'm going to bring this other website up. I'm going to type in that address. Okay? Copy and paste. I'm going to type that address right here into this website called Mac Vendor Lookup. If I can get it to go in there. Okay, and hit enter. And it tells me it's an Apple computer. Okay? That's because the first portion of the MAC address actually identifies it as a Mac. MAC address, Mac, come on, you gotta admit, that's funny. Okay, but, so the MAC address is the physical address assigned to the network adapter. In my case, that's it right there. Okay, I'm gonna move this stuff out of the way so we can continue. Okay, this is the first 24 bits are known as the organizational unique identifier, hence the way they were able to determine it was an Apple. The last 24 bits are the unique identifier. Okay. The MAC address is assigned to each device, every network card, every wireless adapter, everything has one. And actually, if you look at mine, there was actually multiple MAC addresses because I have a physical network adapter and a wireless adapter. Okay. Now let's talk about host names. Host name is the name of the computer. Now, and actually, you know what? I don't know if I can find this out on a Mac. We're going to try this right now. If I can find the other file, there it is. On Windows, it's quite easy. You type host name. Look at that. You can do it on a Mac. And my machine is called local. Isn't that? No, actually, it's right there. It's Ken MacBook 2 FA13.local. That is the host name of my MacBook here. This is my MacBook Pro, my second one. I got it in fall 2013, hence the way I came up with the name. .local is just like a .com or something. It's just something it defaults to. In Windows, you can do the same thing. You can type host name, and it will tell you the host name of your computer. Alright, so the fully qualified host name can also be known as this. Let's ping somebody. This awesome website, google.com. Okay, so I typed ping www.google.com. .com is the top level domain. Google would be the second level domain or the secondary domain, and www would actually be the host name, which would mean that is the web server at Google. Okay, easy enough. You could also ping like mail.rose.edu. There you go. Well, actually, do they have one? Yeah, they do. Okay. So, you will see here, I pinged mail.rose.edu. There's our top-level domain, our secondary domain, and our host name. So, the fully qualified domain name would be mail.rose.edu. Okay? Alright. Domain names must be registered. You can register with Network Solutions. You can register with all kinds of people. They come through ICANN. You can do ARP.mil, edu, gov, but now you can also have sex and church and all kinds of other ones. Okay? Now they're talking about here, name resolution is the process of discovering the IP address of a host when you know its name. Now I don't know if I can do this on the Mac. I never tried. NS lookup mail.rose. If I spell it right, yes I can. So I typed in NS lookup. Where did I type? Well, where'd it go? Right there. and let's look up mail.rose.edu. That stands for name server lookup. And it said, okay, the server I'm currently using is this one, which happens to be my local machine. Now, it says the address. The address is 192.168.2.1, pound 53. That means I queried on port 53. DNS, which we're going to learn here in a little bit, uses port 53. So I contacted that server on port 53, asking it what is the address of mail.rose.edu, and it returned that IP address. Easy enough. Now I could do it the other way. 164.58.104.79. Now this way I'm giving it the IP address looking for a name. So you can go either way. And you'll see they both gave me the same results. But the second one is different. It actually gave me mx2.rose.edu. So in other words, mail.rose.edu and mx2.rose.edu are the same, are different names for the same IP address. Okay? Now something I don't think the chapter is going to tell you about, but in here you'll see where it says non-authoritative answer. See that right there? What that means is it's been cached. My machine did not contact Rose and ask us for its information because my machine knew about it already. Okay? When you set up a DNS record, you have an expired entry where basically we can cache it for so long. And when it's cached, you get that. Let's look up something else. Zombo.com. I haven't looked up Zombo.com in a while, and still non-authoritative. I couldn't find it anyway. Oh, Zombo, not Zombone. Jeez, who's typing today? Darn it, that one's even cached. But I could probably keep querying names or domains until I got one that was not cached. But all that means is it's been cached. Okay? Let's moving on. All right. Here is a bunch of names. Get a drink here. Okay. You'll see all the top level. Com, edu, gov, org, net, so on and so forth. Those are no longer... in the past, that's how you could identify them. Not so much anymore. For instance, .org used to be for nonprofit. Not always anymore. Okay? .net is for a network provider. Not so much anymore. I mean, it still is, but other people can use it as well. Okay? There's a lot of other names available as well. Okay, DNS, Domain Name System, is an application layer client-server system of computers and databases made up of these elements. Name servers, namespace, name servers, and resolvers. DNS is kind of like the blood, or the heart and blood of the internet. If you screw that up, you're done. Okay, this is what we use to resolve names. Okay, the namespace is the entire collection of names associated with IP address stored in database. We have name servers; those are those that resolve. If you looked over here, it told me the server, that was the name server I queried, which happens to be my router, and you can always query Google. Google has a publicly addressable DNS server. They have a second one as well. There you go. A second one as well. So those are DNS servers that Google has made available for everybody to use. So if you're ever at home and your internet's not working, just try changing your DNS server. That might fix it. Okay. Resolver is a DNS client that requests information from a DNS server. I was a resolver a second ago when I was querying information. Okay. All right. DNS servers are organized in hierarchical structure. There's 13. There's actually it wasn't a virus, but it was something where they took down 11 of them. Didn't hurt the internet at all. Okay. Pretty amazing. So at the root level, there's 13 of them. What they hold is the top level domain server information. So when I typed zombo.com, where did I type it? Right here. What happened is my machine, well, let's pretend this is not cached. Okay, this is a new query. Okay, pretend it's not cached at all. It's a new query. So I'm saying name server lookup zombo.com, and I'm going to ask Google. Okay, what happened is well, pretend Google's never heard of this place either, because they would cache it as well. Pretend nobody has cached this information anywhere. So I'm sending a request for zombo.com to Google. Google's like, am I in charge of zombo.com? And I'm assuming they're not. Hopefully they're not. Actually, this is a very good time to show you something very, very important. Here we go. If you've never seen Zombo.com, what? Wow. Okay, you need to check this out. Zombo.com is amazing. All right, check that out someday. But okay, continue on where we were. All right, so name server lookup for Zombo.com. I send it to Google. Google's like, am I in charge of Zombo.com? And their answer is going to be no, because they're not. Well, they've never heard of Zombo.com because they do not have it cached. In other words, it's not in their short-term memory. So what they do is they send a request to one of these 13 root servers. They said, hey, who's in charge of the .coms out there? Okay? There is one server in charge of .com. So the 13 servers, one of them would reply to Google and say, hey, this guy out in the middle of who knows where is in charge of .coms. And depending on if the query was made recursively or non-recursively, either Google would return that information to me, then I would ask them about Zombo.com, but most likely Google would make a request to that .com server and say, hey, Mr. .com, I got your information from the root server here. What can you tell me about Zombo? Then that .com server would say, hey, I heard of Zombo.com. Zombo.com is over here somewhere. So at that point, that .com server would return the address of the name server of Zombo.com to Google. And since that's all I asked for, I didn't ask for a host name or nothing, Google would then, this is Google, remember that, Google would return the address for the name server in charge of Zombo.com to me, and then it would return the IP address. Okay, easy enough. It sounds difficult, but it's not. Okay. Alright, so top level domain servers hold information about authoritative servers. Authoritative means you're in charge of it. When I ran my ISP, I was in charge of all kinds of different servers. Not servers, well actually servers as well, but domains. I was authoritative for those domains, which means I managed them. If anybody on the internet looked for intelgymnast.com, for instance, they would contact the .com server, and they would, they'd contact the root servers. They would tell them where to find the .com server. The .com server will then say, hey, this Ken Dewey guy over here is in charge of intelgymnast.com. And then I would, at that point, return their IP address, whatever they want, the host name, or whatever. Okay, because I was authoritative for them. Okay, there's a picture of it. The root servers, top-level domains. Then we have the secondary, and then these, like this Google.com server, would be the one that would return the www and the whatever number of Google. Okay, continue on. Okay, wow, just what I told you. So, we're going to start. I'm a client. I ask my local server, but in the example I was querying Google, they go out and ask the root name server, and that returns to Google. Then Google then asks the top level, which would be Zombo.com server. Then it'll go out and ask, Zombo.com for whatever, www.zombo.com. Then it returns www.zombo.com to me. So, easy enough to do. Guess I should have looked through all the pictures before I explained all that. But that's okay. I think you got the plan there. Okay, how name servers are organized. It says the resolution process, caching only. Okay, first of all, when you set up a DNS server, there's multiple types. That's what we're talking about here. Caching only server does just like the name says. It caches queries. Because the odds are, if someone in your organization is querying Facebook.com, somebody else is going to be querying Facebook.com. So why make two requests outside of your organization when you can actually have a server inside your organization that caches the information about Facebook.com? That's what a caching one is. When it receives a request for a domain that is not stored in this cache, it gets it and stores it. That's it. Okay? Okay. Sometimes servers inside of a company might not have access, so that you might have to do it that way. Okay? It says the top-level domain name server might be aware of intermediate servers rather than their authoritative servers, because you can actually have subdomains, or you can go really in-depth with the name resolution process. Aha! Here's the two types I told you about. Remember when I said depends how we're set up. Recursive is the query that demands a resolution to the answer. It can't be found. Okay. And Iterative, a query where the local server issues queries to other servers. So, Recursive, I asked Google, it said, I don't know. Iterative, I would ask Google, the Google would ask the root server, the Google would ask the top level, Google would keep asking everybody, then Google would finally return the result to me. Okay. Recursive and iterative, it's not overly critical unless you're actually setting up a server. If you want to return results or if you want to be the one that queries them. Okay. It actually makes a big difference at that point. Okay. Follows a distributed database model where different people are in charge of different things. A zone, for instance, is like zombo.com. The primary DNS server is the one that's authoritative for a domain. For instance, we have ns1.rose.edu. That would be a name server at Rose, and it's most likely authoritative. In other words, it contains or holds the information about rose.edu. Okay? You can also have secondary servers that have a backup copy of it. Zone transfers is when you copy a zone from one to another. For instance, when I ran my ISP, sometimes I would transfer domains from other people to me, especially if they were buying them. Say I'm buying, or I'm going to start hosting, inteljimnest.com. So contact the company that that's getting rid of it, and I would do a zone transfer, transferring their zone to me. Okay. It's not difficult. Bind is the software. Berkeley Internet Name Daemon, that's how it really started. See, when it originally started, we had nothing but a host file. Okay? Because it was only, 4 computers on the internet. But then, started to grow and you made DNS. But Bind, and Bind 8.4, I think was one of the most popular ones that came out. But it's open source. It works with everything. Works with Linux, works with Windows, works with Mac, works with everything. Okay? All right. Bind you'll normally find on Linux machines. Okay, Microsoft, they have their own, but they all work together. Now they also mentioned on the last bullet there a split DNS. For instance, at Rose State, I'm not there right now, so I can't show you this, but they have a split DNS design. In other words, mail.rose.edu when queried from inside gives a different address than mail.rose.edu when queried from the outside. Okay. Same thing happens in our CyberLab network. We have internal addresses. For instance, our licensing server, internal is 10.10.05, external is a different address. Okay, that's what you can kind of think of split DNS. Okay. However, internet, we could have an external DNS service inside of DMZ, which stands for demilitarized zone. Then a firewall, then an internal address. So these guys querying, they might get a different address for something internal than they would for something external. Okay. All right, there's several types of records. We have A records, AAA records, which are IPV6. A is a host name record. Okay. It's an address or a host name known by 2 different things. www.google.com. www would be the A record or the host record. AAA is just an IPv6 version of it. Canonical name or C name is an alias record. Okay, I showed you the example where mail.rose.edu and ns2.rose.edu were the same. That's a C name. Actually, let me see if I can get that to do that for you. I'm going to go nslookup ns2.rose.edu. No, it was mx2, wasn't it? I think it was mx2. mx2. Okay, now let me do it for mail. Yeah, naturally it's not going to show it. Okay, well, I can't. They don't have their setup that way. But sometimes you can actually see this in alias. Actually, let me try Google. No, they're not going to show it either. So it could just be the way that this machine returns the results as well. But a C name is an alias. Pointer is used for reverse lookups. You know when I was looking up the name to the number, then the number to the name? The number to the name is a pointer or a reverse lookup record. Okay. MX record is mail exchanger. Whenever you send email, it has to query the mail server, and that's how that works. Okay. Okay. Let me pause for 1 second. All right. Now I'm going to continue. Okay. We just got done talking about, if I can get the right darn thing to work, we just got done talking about the MX record. The next thing to talk about is dynamic DNS. There's actually a lot of services out there that provide it. I'm going to actually show you one. ta-da, through the magic of the internet, there's mine. I don't own, but I have a service on dynamicdns.com, dydns.com. So if you notice, this address right here, dewey.mine.new, resolves to this address, neary.mine.new, and so on and so forth. Actually, why do I still have that one? It's fixing to not work anymore. I'm going to delete it. Delete you. Hopefully not using it anymore. Okay, so what this is dynamic names. Okay, my host here at my home, if I was to bring up this awesome website, if you've never seen it, IP Chicken. IP Chicken tells me my local address. Okay, so if you look, it ends in 188.19. So there's 188.19. That address resolves to dewey.mine.new. Okay, this is a service that's free, I think, for one address. I have a lot more. Because way back when I first started using this thing, I gave them 20 bucks. So it's pretty awesome. We're talking back in the mid-90s. It was a nice service. And I'm one of those that if I use your stuff and I like it, I want to pay you something. So I paid them 20 bucks back in like 1995. So I got a pro account that's good for like 30 addresses. And I've never paid them a penny since. See, mine never expires. Nowadays, I think you actually have to pay a little bit to use the service, and I think you only get one. I'm not positive. We used to have some cams at Rose. There's a friend of mine. There's another friend of mine. There's my son's address, and so on and so forth. See, I can have multiple addresses in here. Okay? Wow, I do have a lot. The parish. Wow, I don't even know how these people are. Okay. But you'll see. So this is what's called dynamic DNS. Okay? It's a protocol along with monitoring software to monitor your IP address dynamically, and I can run it on my machine here. I'm not running it currently, but if I was, I could run it, and if my IP address changed, it would notify that website, and that way, if I wanted to connect in remotely, I would know the address. Okay. Manages dynamic updates to the DNS records for mine. Now, if you're wondering why I have mine.new, I don't have to. It's just that it was just something I used way back when, and it's easy to remember. I can go add new host name, and I can pick from a whole selection of host names. Holy gee, look at all them names. Okay, is a blogger, is a chef, is a geek, is a knight. Wow, there's a lot of names in here. Is an actress I saw, is a techie. Which probably is a loser in here somewhere too, I don't know. Oh, it is very sweet.org. Isn't that neat? But you can actually pick the extension, and then you give it a host. Like I could say Ken dot. That's a stupid one. Can't pick it back up for this example. Now, I'm going to be a chef today, so I could have Ken dot is a chef.net. Get an IP address, and I can even assign my local one. Then from that moment on, you could type in ken.isthechef.net and it would resolve to that address. Easy enough. So, a lot of routers supported automatically. Okay, ports and sockets. Let's talk about this. Kind of important. Okay, this is very important. Port numbers ensure data is transmitted to the correct application. Think of a port number as like a channel on a television. Okay? I can have cable, so I have one connection to Cox, but I have a bunch of different channels. In this example here, I have an IP address, and this is a port. This is port 23. So I can have multiple different channels, and I actually have multiple different channels here. Might not be a good idea to show you this, so let's try something. Well, I can't figure it out. Not like that. Well, I can't show you at the moment. Well, maybe I can. Hold on. Maybe I can. Okay, I'm going to bring up something here. I'm doing it on the screen. I'll transfer it over here in 1 second. And there's my ports. Okay. Here we go. This is my home router. Okay. For instance, I have a camera. But this camera is actually turned off right now. But I have a camera. If I was to do edit, you will see I have an external port of 8082 at this IP address. Now, my external addresses at this port translates to this internal address on this port. So if you to connect to dewey.mine.new :8082, actually, let me show you one that's actually working. Let's go to 8080. So I'm going to bring up this one. So if I was to connect on Dewey.mine.new colon 8080, what happened is it connected to my solar system. Okay? So you'll notice the solar system here. The external port was 8080. So I typed in Dewey.mine.new, which was learned through dynamic DNS, results to me. And that port, and it translated it once it hit my machine to this internal address on port 80. To prove that, if I was to type in that internal address, 192.168.2.202, port 80, I don't have to put a port number. There it goes. It comes right up as well. So that shows you I can either connect via the internal or the external address. Okay? All right. That's just an example. Let's get rid of that. All right. So what a port is this number at the end. 23 is telnet, for instance. This is saying connect to this IP address on port 23, which is telnet. The two combined becomes a socket. So the IP address and the port becomes a socket. Okay. We have a couple different types. We have well-known 0 to 1023, registered 1024 to 49151, and then dynamic above that. You can use any port you want for your network. Okay, it's just like port 80 obviously will work for a web server. Okay, port 25 would work for your mail server, so on and so forth. Okay. All right, here's our client, and here's our server. Makes a request out on port 23. Connect to the server on port 23. Then it sends the data back to the client. Easy enough. I just showed you a working example. Okay, IP addresses. We have two different types: IPv4 and IPv6. You have IPv4, which is only 32-bit addresses, IPv6, which is 128-bit addresses. You will learn a lot more about that throughout this degree program, but IPv4, we're out of them at this point. We're all using, well, we're transitioning to IPv6 addresses. Okay, IPv4, 32-bit address organized into 4 groups of 8 bits, known as octets. Each of them can be between 0 and 255. Some are reserved. For instance, 127.0.0.1 is reserved. 10.10 is reserved. 172.16 is reserved. 192.168 is reserved. There's a lot of reserved areas, and as you learn this, you will obviously learn those. Okay. Classes. Way back when we started the internet, someone said, hey, let's make some classes, A, B, C, D, and E. It don't work no more. But the original intent was A was for large addresses. The first octet was all that was used for the network, and the rest were for hosts. B, the first 2 octets were the network, the last 2 were the hosts. C, the first 3 were the network, and the last 1 was the host. And D and E were multicast and experimental. Okay? Okay, so here it is again. Class A, again, the first octet you used could hold 126. And the last 3 were for the host. You can see here, the last 3 octets, so you could have 001, 002, 003, all the way up to 255, 255, 255, or 254. Okay? So you could have 16 million hosts, but only 126 addresses. Now, this isn't actually, they call it octet 8 bits. 2 to the 8 is 256. So if this is an octet for 256, why is there only 126 addresses? Because a lot of them can't be used is why. Okay. Class B, the first 2 are the network, the last 2 are those. You basically get 65,000 addresses, 16,000 networks. Again, some of them can't be used is why that's not. If you think about it with Class B, they're equal size, you should have the equal number. Well, you don't. Okay. Class C, a lot of addresses, small number of each, only 254. Okay. Well, if this is an octet, it will be 2 to the 8, 2 to the 8 to the 256. Otherwise, it's 254. Well, we're going to get into that here in a little bit. Okay. Reserved addresses. 255, 255, 255, 255 is a broadcast address. Can't be used. All zeros can't be used. 127 can't be used. 196. There's just all kinds of them can't be used. They don't show the rest of them? Well, that's pretty stupid. But there's a lot you can't use. Okay. Now let's talk about DHCP. Okay. Static addresses are assigned manually by the network administrator. So if you had a machine that needed a particular address, for some stupid reason you couldn't assign it automatically, you could assign it statically. The administrator would assign it an address. Dynamic addresses are assigned via the DHCP server. Okay, my router is my DHCP server. Okay, so it says if a computer is configured to receive addresses, well, then it gets them. If not, it has something called APIPA. If you ever looked at your machine and your IP address is 169.254 something, that means something is wrong with your DHCP server. Because if the DHCP server is not answering, the IPv6 or IPv4 APIPA will automatically give you this. It's great for troubleshooting, and yeah, it's just wonderful. I can't show you an example because I have an address. But if my server was not giving out an address, I could get that. Okay. All right. Public and private addresses. Again, we talked about A, B, and C. Those are all public. Okay. Those work on the internet. Private are those internal. Normally, private addresses are the 10s. That's like what we have at Rose State. And if you notice, my address at my house is this right here. I have 192.168.2. You guys probably have a .1 or a .0. But these are all private. They will not route on the internet. Okay? So they work internal. Okay. NAT, Network Address Translation, is a technique designed to convert external address to internal address. I showed you on my router a few minutes ago how that external address for dewey.mine.new translated to an internal address at 192.168. That's called network address translation. Okay, so it's a process where the gateway device substitutes the private address. So now when I surf the internet, see, my IP address of my machine is 192.168.2.203. When I surf the internet, it actually goes out as my router's address because the NAT takes care of that for me. This port address translation, that's kind of what I was showing you as well, where the ports were changed. Remember, I connected on 8080, and it translated it to 80. All right, so here we go. We have our gateway. This could be my gateway or your gateway. These are your internal machines. They surf the internet as this address. That way, when the packet comes back, it can translate it back. And you see here they have some different ports. This is exactly what I was doing. My external port was 8080, my internal was 80. I have the same, I have different cameras, they're all on different ports. So the external address resolves to an internal address of the camera. Easy enough. Okay. It's two versions, static and dynamic. Static is what I showed you. I manually assigned those myself. I configured my router to manage that. But you can have it done dynamically. That's actually what happens for the rest of you. If you don't know it, if you don't know what you're doing, it's happening automatically, okay? It automatically is translating your internal to your external. Okay. IPv6 is 128 bits. That's 10 and 38 zeros, I think. In other words, a lot of addresses. Okay. So an IPv6 address is 128 bits written in 8 blocks of hexadecimal numbers. Okay. I'm pretty sure you can have an assignment trying to figure out how to do hexadecimal numbers. Okay, there's 4 hex digits in each one. Okay, leading zeros can be left off, and if you have a lot of zeros, here we have multiple zeros right here. We could actually replace them with a colon. See these right here? All these zeros, 2 groups of 4. You can wipe them out and replace it with just these 2 colons down here at the bottom. Okay, so if the block contains all zeros, just use the colons. Easy enough there. Okay. IPv6, link, sometimes called link local. Any LAN bounded by routers as the interface is the node's attachment to the link. We also have tunneling. That's a way of sending IPv6 through IPv4. So it says a method used by IPv6 to transport IPv6 over an IPv4 network. They are fully compatible. Okay. An interface ID is the last 64 bits. So this ending part here is actually the machine's address. The first part is the network. Okay, so the last 64 bits is the last half basically is your interface ID. Okay, neighbors, 2 or more nodes on the same link. Okay, wow, that's pretty handy. Okay, Now wow, that's all they talk about that? Wow. Well, we have another presentation on that, which I will make available if people want it. I'll use it in my classes. All right. So, unicast addresses. Unicast is a single node on a network. So I'm going to bring up my thingy mahoozy over here again. So if I want to ping, I'm going to ping my router 192.168.2.1. Okay. Oh, the front door was closed. Great. That's turned off. Okay. So I pinged it there and I stopped it. What I did is I sent a ping to this address. Well, what it did is it resolved the MAC address and actually set the data to the MAC address. This is a unicast. It went directly to one machine. Okay. Multicast. Well, yeah. We also have global unicast and link local address. These are different types of unicast address on a V6 network. Okay, IPv6. Multicast is like a broadcast. I don't know if I have Wireshark on here. Let me find out if I do. I do not, so I cannot show you that example. But I'm sure you'll see it in one of your classes. Multicast is like a broadcast. Okay, packets are delivered to everybody on a network. It's kind of like think of it like Walmart. Okay, if someone left their lights on, actually I don't even think they do this anymore. But in the past, when people were friendly, if you left your lights on in your car, you'll be in the store and they say, "Excuse me, the person in the white car left your lights on." So that went out to everybody in the store. Okay, they sent out the notification one time. Everybody received it. You hope. Okay. Unicast, they would have had to go to each person in the store and say, "Hey, did you drive that white car? You left your lights on." Okay. So that's the difference between multicast and unicast. Unicast, they'd have to go each person individually. Multicast, it goes out to everybody. Now with unicast, they know they talk to you. You know, nowadays, a lot of people wear headphones all the darn time. If you're wearing a headphone and they use a broadcast on the loudspeaker at Walmart, you can hear it? Probably not. But if they actually walked up to you like unicast and said, "Hey, are you driving the white car?" they would know you got it. So those are the two main types. Anycast says can identify multiple destinations with packets delivered. We're going to talk more about that at another time. Not tonight. Okay. So there's our broadcast, one to everybody. Multicast could go to multiple people. Anycast is pretty much the same kind of thing. If you notice the pictures, they're nearly identical. And then unicast goes to one specific person. Okay. All right. Types of IP address. This is an IPv6 address. You will notice we have 001. I think we have a separate presentation on IPv6, which we will make available, and there will actually be an assignment to go with it. So we'll make sure that's available for your Chapter 2. I know you guys are so excited. But I'll make it available to all the adjuncts so they can have it. So, because I made it myself, it goes in a little more detail, a lot more than I'm going to go in now, on IPv6. Okay? But they talk here about different types of addresses. We have global unicast, we have link local, unique local, and multicast. And again, I go into that in more detail in the other presentation. And if you're looking at your machine, if you type ipconfig on your Windows machine, you'll actually see there's your IPv4 and your IPv6. Where is your IPv6? There it is. There it is. There's your IPv6 address, and you'll see this is your link local. This is kind of like your internal network ID. Okay? All right. IPv6 Autoconfiguration works kind of the same way as the IPA. Yeah, wow. Okay. All right, it says it creates two IPv6 addresses, uses the first half and the second half. The last 68 can be generated randomly, kind of like that 169.254 that was generated randomly. The 169.254 was hard-coded, but the last two octets were generated randomly. All right. The same way it works in IPv4. Once it picks a random address for the last half, it checks to see if it's unique. If it is not unique, it generates another one. And that's how it works. Okay. Then it asks the router if it's available, then it assigns it. Okay. Easy enough there. Okay. Tunneling. There's actually a website called, let me see if we can find it here. I'm going to bring this over. Wow, I'm generating no power right now. Well, that just sucks. Well, maybe it's because it's nighttime. Okay, let's go. I think it's Hurricane. I think it's Hurricane Electric. Is it? There it is. Hurricane Electric. You can actually get a free IPv6 address from these guys. Totally free. Okay, maybe I'm lying to you. They had totally free ones. I think it was free for personal use. All kinds of... Where the heck is it? There it is, right there. Free IPv6 tunnel. You can go there, and you can actually get a IPv6 address that could be yours forever and ever and ever. So again, this is Hurricane Electric, and it translates to tunnelbroker.net. Okay? Alright. Different types of tunneling. We already talked about tunneling. That's where you can tunnel IPv6 over IPv4. Okay? It says if packets and networks must traverse other networks where dual stacking is not supported, tunneling is used. We have 6-4, ISAPA, and Teredo. Again, I have another presentation which goes into these in great detail, and these slides don't, so I'm going to not talk about them much here, but they will be covered more later. Again, here we have a 4-6 tunnel. That should show you. We're not showing you any errors. Okay, but example. All right, and even on, here's an example of event viewer showing a problem with your tunnels. That's enough for IPv6. But again, I will make sure you get the other presentation on that. Okay, ping. Packet Internet Groper. Isn't that kind of a cool name? Used to verify if a host is online. Okay. A few minutes ago, right here, I pinged my router. What it did was it sent 64 bits of data from my machine to my router. Basically, hey, are you there? And it came back and says, yep, I'm there. Yep, I'm there. Yep, I'm there. Yep, I'm there. And you see the different time. Now, if I was to ping Google, the time should be higher. Now, if you notice, this is my internal router right here. You'll notice these times are very fast. The slowest is only 1 millisecond. Now, when I ping Google, obviously that's an external address. You'll notice that the ping times here are a lot slower. 15, 18, and 64 milliseconds compared to 0 and 1. Okay, so ping sends the information out and it comes back. Okay, there's actually a movie, bring this back over here, called Warriors, come out and play, of the .NET, Warriors of the .NET, think. There it is. Okay, there's a movie, Warriors of the Net. You should watch it. It's free. See the movie right there. It's literally, you can watch it right here. And it shows you how the internet works. And it has the dreaded ping of death. Oh, look at that. Isn't that scary? His own. Look at that. Kind of a cool movie. He's fast. He's strong. He's TCP/IP. And he's got your address. Okay, that is Warriors of the .NET. You need to go watch it. That's not very long. It's a cool movie. Okay, and he has the dreaded ping of death. Okay, so the ping utility sends out a signal called an echo request, and it comes back with what's called an echo reply. You'll actually see the reply here. One's a 0, one's an 8. The reply is an 8, but don't worry about that for now. You'll learn that later. Okay, it's part of what's called the ICMP. In other words, the Internet Control Messaging Protocol. Okay, this protocol handles requests and replies, and it's really to check connectivity. Ping is not used much anymore because a lot of places block it. Let me see if I can find an example of somebody blocking it. Let's try pinging Yahoo. Ping Yahoo. Yeah, naturally, it's still working. Suck. Thought these guys used to block it. There it is. There we go. I got one. Okay. So if you noticed up here, Google replied. Yahoo replied, but not eBay. eBay didn't reply because a lot of places started to block it for security reasons. Okay. Because, I know I keep bringing this back over here, but just because of this, now I know Yahoo's number, and I know that they're up and functioning. eBay, I don't know a damn thing. I do know their number, but I don't even know if they're live. I can't even tell if they're online or anything. I know for a fact Yahoo's up and running, so if I wanted to attack them, I know they're there. I don't have a clue if eBay's there or not. eBay might be out to lunch. Okay? All right, let's continue on. Okay, so we have ICMP. Let's move on. So we can ping. We can ping anybody. Okay? You can ping a name reserved to a number. You can ping a number. You can ping with a -A. You can ping with a -T. The -T is kind of cool. -T on Windows will go until it's stopped with a Control-C. Now on a Mac, it automatically goes forever. Okay? And you could also do the size. It's -L, which I don't see on there. I think if I actually just type ping, it'll actually show me the commands. There should be a -L for size. Let me see L, G, preload, math, time. I don't see time. I don't see L, but I know L's there somewhere. Damn it! There's the -T. A. Okay, we're gonna find it. Sleep size G. L. The preload. Yeah, I guess that's it. Okay, the L right there. The preload is the actual size of it. So you could send a larger packet. Okay. All right, ping works on IPv6 as well. It's called ping 6. Same kind of thing, but you can ping an IPv6 address. ipconfig, I showed you this already. ipconfig can return information about your network configuration. Returns all your information. You can also release, you can renew, you can release 6, renew 6. You can display your DNS, and you can also flush your DNS. I can go in here and type ipconfig / display DNS, and we'll see. What? I guess I can't do it on a Mac. Can't do it on a Mac. You have to do it on Windows. But it will show you your DNS information. Nope, sorry. Actually, this is one of this used to not be allowed on a Mac at all. So I'm surprised it still works at all. But you can do display DNS, and it'll display all your currently resolved addresses. You can also clear it with flush DNS. Okay, ifconfig is used on Linux. And I can do the same thing here. Actually, I think I did already once, but I can do ipconfig here. But I also can do ifconfig, which show me my interface information. Okay, I can bring it up, I can bring it down, I can see the information about it. I can also see the help pages about it. So that's on Linux and Mac systems. NSLookup, I've been using them on the whole bunch. I can use it to query name server information. I can do interactive, or I can do a lot of queries at a time, or I can do non-interactive, which is what I was just doing at that time. Okay. So here's an example. We're doing NSLookup of Cengage.com. Again, it comes back non-authoritative. Okay. Or I can just type NSLookup by itself, and then it gives me a prompt, and then I can put in a bunch of different, I can type in the server, and I can type in all kinds of information at that point. It's normally used in the non-interactive mode, okay? Like this up here at the top. All right, that is the end of this chapter. Yay! Aren't you excited?